When you listen to a lecture in class, the language used is probably very formal. Grammar rules are observed, and syntax and vocabulary can get quite complex based on the topic. Some other examples of the use of formal language can be found in courts and other legal institutions. Now let's consider the way people talk in their everyday life. There's lots of slang. Grammar rules are bent and broken, and the entire delivery is colloquial. There are many styles in every human language, and they all perform the exact same function: communication. The same can also be said about computer languages. They too have various styles, also known as programming paradigms. And just like in human languages, no one style is better suited than the other. In programming, there are two commonly used paradigms: functional programming, sometimes abbreviated as FP, and object-oriented programming, sometimes abbreviated as OOP. You can think of these paradigms as different approaches to writing code. But the result is still the same: instructing a computer to perform a set of operations. In this lesson, you will learn about functional programming. So let's now focus on the functional programming style. There is a clear distinction between data and functions in functional programming, as data can exist outside of functions. For example, you may recall that when functions need some data, you pass them the values in the form of arguments. Then a function performs some work on the given data and returns some values that you can then use somewhere else in your program. An alternative paradigm is the object-oriented programming paradigm, where you combine both data and functions into objects. You'll learn more about object-oriented programming later. Now let's examine a practical implementation of the functional programming style using a coding example to calculate currency conversion. Okay, so in this example of functional programming, let me start by giving my program some data. The purpose of the program is to perform currency conversions. Notice that I already have a variable declared with the name currency1 and assigned it the value of 100. Next, I'll add two more variables: currency2, which is assigned a value of 0, and exchange rate, which is set to 1.2. Notice that I have declared all these variable names using camel case. This is where the first letter of the first word is lowercase, and the first letter of the subsequent words are without spaces and in uppercase. Next, I can create the function that will work with these variables and operate on this data. First, I create a function named convertCurrency that accepts two parameters, amount and rate. Then, in the function's body, I return the result of the amount multiplied by the rate. Basically, I'm coding it to multiply the two values it receives and return the result. Next, I need to update the value of currency2, which was previously defined on line 4, assigned to the value of 0. To do this, I call the convertCurrency function with arguments of currency1 and exchange rate, and I assign the value returned from this function call to the currency2 variable. Recall that when the function is invoked, it will return a value, which will be assigned to the variable currency2. It's important to remember that I need to also pass the two arguments required for my function to work. In this example, I'm sending the variables currency1 and exchange rate. Basically, I'm passing the values 100 and 1.2 to the function so it can perform its calculation and return the result. Finally, I console log the value of currency2 to test my code. Success! 120 is output to the console, the result of 100 multiplied by 1.2. In this lesson, you learned about functional programming and how it can be used to solve a problem by separating data from functions. Great job!
Treadmills are a useful piece of equipment for doing cardio at the gym or when running outdoor isn't an option. They are also easily started with the push of a button. Imagine, however, if there was no way to control when a treadmill stopped. That wouldn't be ideal, would it? Fortunately, most treadmills have a function that tells the treadmill to stop after a specified amount of time. Thank goodness. In JavaScript, functions that repeat tasks are similarly helpful unless they run endlessly. In this video, I'll demonstrate what recursive functions are and help you understand how to write them properly to avoid getting stuck in an infinite loop. To call, invoke, or execute a function means instructing it to follow the code inside of it one line at a time. To demonstrate, let's first build an example. type function example parentheses, then left curly brace. Press enter to advance to the next line and type console.log. Inside of the parentheses, type quote line 1 unquote, and then close off with a semicolon. I now have one line of code, but let's add a few more. On separate lines, I input 2 more console.log lines as I did before, but this time containing the strings line 2 and line 3 respectively. I close the function by inputting a right curly brace. I've built a function called example with 3 lines. When I run it, each of the lines will be executed one at a time in sequence, producing 3 strings. To make things interesting, let's add one more line to the example function. This time, type the name of the function itself. So that's example parentheses semicolon. Now, if I run the function again, it will repeat in an infinite loop. Obviously, this wouldn't be useful, so let's improve it and ensure that it won't run endlessly. I add a new line before the function and type let counter =, 3 semicolon. Next, I delete my 3 console.log lines, which I'll replace with some different code. For the first line, I type console.log and then counter inside of the parentheses. On the second line, I type counter =, counter -1 semicolon. And finally, for the third line, I start by typing if, and then inside of the parentheses, I type counter =, 0, and then I type return and a semicolon. If I call the function this time, it will log the numbers 3, 2, 1, and then stop. When a function calls itself, this is what's known as recursion. Recursion is an alternative way to run repetitive code without the use of loops. Next time you see someone running on a treadmill, imagine a function running in the background. It might be calling itself to continue running until its condition is met to stop. In this video, you learned about the uses and potential problems of recursive functions and how to write them so that they don't run endlessly.
Scope is all about code accessibility. It determines which parts of the code are accessible and which parts are inaccessible. For example, what variables can a function access within code? Over the next few minutes, you'll explore the concept of scope and learn about how the scope chain works within JavaScript. You will also explore some of the different scope types, such as global and local. A nice way to think about how scope works in JavaScript is a two-way mirror glass. This is a piece of glass where only one side is transparent. For example, if a restaurant uses two-way glass, people outside the restaurant can't see what's happening inside, but the people inside can see what is happening outside. The process is similar to how scope works in JavaScript. For example, the code that exists outside of a function is referred to as global scope, and all the code inside of a function is known as local scope, or function scope. If a variable is defined within a function, then you can say it's scoped to that function. This is also known as local scope. For example, I could define a variable named local var and place it within a function. I could then say that this variable is scoped to the function in which it was created. Each function keeps a reference to its parent scope. This chain of scope references is referred to as the scope chain. You're now familiar with scope and how the scope chain works in JavaScript. You can also identify how some of the different types of scope work, including global and local, also known as function scope. You might recall that scope relates to code accessibility. It determines which part of the code are accessible by different parts of the program. In this video, you will explore scoping in more detail and learn about 2 more scope types and how they work with the keywords var, let, and const. You may recall that all the code outside of functions is referred to as global scope, and all the code inside of a function is known as local scope. Local scope states that a variable is only accessible in the function where it is declared. In the ES5 version of JavaScript, only functions can build local scope. The ES6 version of JavaScript introduced a new variety of scope, known as the block scope. Block scope states that a variable declared in a block of code is only accessible inside that block. All the other code outside of the code block cannot access it. Block scope is built when you declare variables using let or const. In other words, when you build variables with let or const, they become immediately scoped to the code block they were created in. The scope of these variables is contained within curly braces. For example, you can declare two separate variables with the same name if one is declared inside curly braces and the other is not. You can then only access these variables inside their scope. Before ES6, the only way to declare a variable in JavaScript was to use the var keyword. The var keyword is very lenient. Let's outline some characteristics of variables that are declared with var. First, you can use it in your code even before it is declared. Also, you can redeclare the same variable when you use var. And the variables are scoped to a function, or if they are declared outside a function, their scope is global. With ES6, the suggested way to declare variables is to use the let or const keywords. Its syntax is very similar to the var syntax, only the keyword is replaced. For example, let's say you want to declare a variable named user and assign it to a string set to the value of Miranda. In ES5, you use the keyword var, the variable user, the equal operator, and then the string value Miranda inside double quotes. In ES6, with let and const, you use the same syntax, only changing the var keyword to either let or const. Note that the syntax is very similar. Okay, so you might be wondering what's the difference between var, let, and const. The simplest explanation is that the behavior of let and const is more strict. With a let or a const variable, you cannot use it in your code before you declare it. You cannot redeclare it using the variable keyword, like you can with var. Finally, it's scoped to the block, even within if statements and loops, like the for or while loops. If you are new to JavaScript, it may be confusing as to when to use either var, let, or const. A pro tip is to remember it like this. Use let if the value might change in the future, and use const if the value will never change. In this video, you learned how the scope of variables changes when you use the keyword var in ES5 JavaScript and when you use the keywords let and const in ES6 JavaScript. Great job!
In this video, you'll learn about the var, let, and const variables and the different rules that they are bound to. Let's start with the var keyword. I've typed some example code that is currently commented out, but we'll go through it one point at a time. A variable declared with the var keyword can be accessed before initialization as long as the variable is eventually initialized somewhere in our code. To confirm that, let's try to console log a variable that hasn't been declared or initialized. I type console.log and then user in parentheses and click the run button. This returns reference error user is not defined, which is probably expected. However, suppose I use the var keyword to declare the variable user as my last line of code and rerun the code. Notice that undefined is output but no error. This means that the JavaScript engine continues to run. Let me clear my window here, and another thing to know about the var keyword is that we can declare and redeclare the same var variable without errors. Let me uncomment lines 9 to 13 in my code to demonstrate. Notice that each line uses the var keyword to repeatedly declare the user variable and assigns it to a different string value, Mary, Joanna, and finally Mark. I'll comment out line 15. When I run my code, it outputs the first value, undefined, and then the value of the latest reassignment, in this case, the string Mark. Next, let's move on to the let keyword. A key difference is that you cannot access a let variable before declaring it. For example, in lines 4 and 5, suppose I run a console log on the user variable as our first line. In that case, I get the reference error cannot access user before initialization. What we can do, however, is declare an unassigned variable with let. Running a console log by uncommenting lines 8 and 9 works without problems and returns undefined. However, once you declare a variable with let, you cannot redeclare it. Trying to do so by uncommenting line 12 will produce the error, syntax error, identifier user has already been declared. While you cannot redeclare a let variable, you can reassign it. For example, notice lines 8 and 15. Initially, it is set to undefined and then to the string value of Anna. Now if I run my code, notice that undefined is output first, followed by the string Anna. Finally, let me switch tabs again to demonstrate the const keyword, which is the strictest. A const variable must be initialized. For example, On lines 4 and 5, you get the syntax error missing initializer in const declaration. Next, let's comment out lines 4 and 5 and uncomment lines 8 and 9. As you can see, you can't access a const variable before initialization or else you'll get a reference error. Next, uncomment line 9 as well as line 12. A const variable can't be redeclared as it throws the type error assignment to constant variable. Okay, and that's it for this video comparing variable declaration using var, let, and const. It might seem confusing at the beginning to know which type to choose. Try to remember it like this. The var keyword is the most lenient, while the const keyword is the strictest. The best choice in use usually depends on whether or not you will be reassigning values. In modern JavaScript, I'd advise you to pick either let or const based on whether they'll be reassigned or not. Why not give it a try in your own practice code?
In programming, there is something known as the programming paradigms. You can think of this as a classification, a style, or just a general way to write code. You may already be familiar with one of these paradigms, functional programming. In this video, you will learn about another popular one, the object-oriented programming paradigm, often referred to as OOP. OOP revolves around the idea of organizing our programs using objects to group related data and functionality. This is in contrast to the functional programming approach, where the data used in the app needs to be kept separate from functions that operate on that data. Let's explore this concept further using some code examples from the two paradigms. Suppose we are asked to write some code that calculates the total cost of buying a pair of shoes. The code needs to calculate the total price, which is the shoes multiplied by the tax amount. To code this solution, you decide that you need variables to store the values for shoes and tax and total price. You need a function, which you will call total price, to perform the calculation of multiplying the shoes by the tax. Finally, you need to be able to output the result. Using the functional programming approach, you clearly separate a program's data from functions that work on that data. With the OOP approach, you create an object and store all data related to that object, including variables, functions, and output statements. For example, you create an object named purchase1. You may recall that functions inside objects are known as methods. Now that the purchase1 object is created, you access the total price method on the purchase1 object using the dot notation. Then you invoke the total price method, which works with data inside the purchase1 object and returns the result of 120. In fact, you can access any data that the purchase1 object has. For example, using the dot notation, you can access the shoes price data and the state tax data. An advantage to using the OOP approach is that you can build as many objects as you need. For example, you can build another purchase object and name it purchase2. Once created, you can also access the total price method on the purchase2 object, just like you did on the purchase1 object previously. You may notice that the total price method was almost the same in both the purchase1 and the purchase2 objects. This means that you can improve the objects so that both methods are identical. And you can do that by using the this keyword, which you may recall. It essentially means this object. It's important to note that the code still works exactly the same as before. Okay, so you may be wondering, why did I go through the trouble of updating the code of purchase1.choosePrice to this.choosePrice? Well, the advantage here is that rather than having to think about the name of the object whose shoes price property I'm trying to access, I just use the alias of the current object's name, namely the this keyword. And now I can just copy the total price method from the purchase1 object and reuse it in the purchase2 object. So, using the this keyword allows me to not really care about the current object's name, which is an improvement to the previous code I had. However, Programmers are always eager to avoid wasting resources when writing code, and coding a custom method on each of the objects I build is wasteful. The solution to this is to code my objects using some sort of a template. You will learn how to create this later in this lesson using something called a class. For now, let's explore object-oriented programming principles with the example of calculating the total cost of buying a pair of shoes. Before starting, let's first quickly revisit another programming style, functional programming. This should help you understand the differences between the two paradigms. I start with var shoes equals 100, and I also add var state tax equals 1.2. Next, I declare a function which returns the value of the shoes multiplied by the value of the tax. This is written as function total price with shoes and tax in parentheses. Inside of curly braces, I add return shoes asterisk tax. Now I'm declaring the variable to pay, which invokes the total price function and passes the shoes variable value, as well as the state tax variable value. Finally, I console log the toPay variable. When I run the code, the output is 120. So that's an example of the functional paradigm. But this time, let's build something similar with the OOP paradigm. I go to a separate file where I declare the variable purchase1 and store an object literal inside of it with curly braces. I then add the property shoes and set it to 100, followed by state tax, which is set to 1.2. The last property is total price, which is set to a function to declare a calculation variable. This variable is equal to the purchase1.choose property multiplied by the purchase1.stateTax property. The second part of the function console logs the string total price, along with the value of the calculation variable. On line 10, I call the function with purchase1.totalPrice parenthesis, which I expect to return a value of 120. I run the code, and that's indeed what I get. On another file, I'll build another OOP example. This one starts with the variable purchase2, which has the same structure as purchase1. However, the shoes value is changed to 50. In the total price function, the calculation variable is updated to access the shoes and state tax properties from purchase2. When I invoke the total price method on the purchase2 object and run the code, it returns a value of 60. Between these two OOP examples, you may have noticed that aside from accessing the shoes and state tax properties in different objects, the two methods are completely the same. This means that I can improve my objects to make both methods identical while getting the same results. I can do this using the this keyword, which essentially means this object. Let's move to another file to examine how that works. In this file, I have the same purchase1 and purchase2 objects from before, with all of the same values. In the total price function of purchase1, I replace the references to purchase1 with the this keyword. I can then copy the total price method from purchase1 and paste it into the purchase2 object, since they are now identical. I run this code and it gives me a total price of 120 for purchase1 and 60 for purchase2. This is an improvement over my original code from the perspective of reducing waste. Instead of writing custom methods for every object, this approach allows for the reuse of existing code. However, although I'm reusing the existing code, I'm now repeating this same method on each new object that is built. That is wasteful, and programs need to be efficient. This is where making templates for objects comes in. In JavaScript, one of the most elegant ways to efficiently build new objects is by using classes. Congratulations! In this video, you learned about object-oriented programming and how it differs from functional programming. With the object-oriented approach, you can code more efficiently by reusing existing code. In programming, there are situations where you need to build many objects that have a certain specific set of properties and methods. For example, you might need to build hundreds of car objects for a car racing game. To code this efficiently, you can use something called classes. They are essentially a blueprint that you can repeatedly use to build new objects of a certain kind, as many times as you like. In this video, you will learn about classes. In JavaScript, any class is built using the class keyword, followed by the name of the class starting with a capital letter, and a pair of curly braces. Inside of the curly braces, you have the constructor function, which accepts as many parameters as needed. The role of the constructor function is to assign the passed-in parameters to the future object's properties. It is the constructor function that is used when instantiating new objects, instances of a given class. After the constructor is defined, you add as many methods as you want. It's important to remember that you don't use the function keyword here, just the name of the method is needed. Once the class definition is ready, you can start building the car objects. Now that you have instantiated the car class and saved the instance of the class as car1, you have access to its methods and properties. For example, to access the turbo on method, you type the name of the object, which is car1, then the dot, and then the name of the method that exists on that object. In this example, the turbo on method, with a pair of parentheses to invoke it. When invoked, the turbo on method will work with the available data in the car1 object to produce its output. Like with regular functions, you can also pass parameters to the class methods and then use them the same as with regular functions. In this video, you learned about classes and how they can be used to build multiple object instances with specific properties. In the real world, inheriting something means acquiring possession, condition, or trait from past generations. In this video, you will learn that inheritance also exists in JavaScript, and the inheritance model revolves around something called the prototype. You may also be familiar with the concept of a prototype, which is often referred to as an original model from which other forms are developed. In JavaScript, the prototype is an object that can hold properties to be shared by multiple other objects. And this is the basis of how inheritance works in JavaScript. This is why it's sometimes said that JavaScript implements a prototypal inheritance model. Let's explore this further now with some code examples to demonstrate inheritance and how to build a prototype. Consider the following object. I'm setting the var bird to an object that has three properties, each set to the Boolean value of true. The properties are has wings, can fly, and has feathers. Using the readily available object create, I can construct new objects. For example, I've set the eagle1 variable to a call that takes the bird object and passes it to the object.create method. I can console log the contents of the eagle1 object now. Let's run the code. And notice an empty object logged to the console. However, since I used object create to instantiate the eagle1 object, I also have access to all the properties of the bird object. So, I console log eagle1 has wings and pass eagle1 dot has wings. And I also console log eagle1 can fly and pass eagle1 dot can fly. And finally, eagle1 has feathers, passing it eagle1 dot has feathers. Let's rerun the code. Once again, notice eagle1 has wings true, eagle1 can fly true, and eagle1 has feathers true, our output to the console. With the object create syntax, I can build as many objects as I want, and they will all have the bird object as their prototype. Here, notice that I built an eagle2 object, and I've used the bird object as a prototype, because I ran the object.create method on it, and I save everything to the eagle2 variable. It's important to understand that the eagle2 object also has access to the properties stored on the bird object as its prototype. Let's run this code to confirm. And indeed, notice that eagle2 has wings true is output to the console. I can even add different objects with different behaviors. For example, I can add a penguin1 object, I do this by declaring a penguin1 variable and assigning the result of the object.create method to it. Penguins are flightless birds, so I want to set the canFly property to false. Thankfully, this is a relatively straightforward process because JavaScript starts from the object itself when looking for properties to work with. Then, if it can't find it on the object, it looks up to its prototype. It's important to remember that it doesn't look further if it finds the property on the immediate object. This makes for a simple mechanism for overriding inherited properties. So let's implement this now. First, I set the canFly property on the penguin1 object to false. And now I can console log the penguin1 object. Notice the output to the console after running the code is that penguin1 is an object with a canFly property set to false. Additionally, I can still access all the properties of the prototype. So accessing the hasFeathers and canFly properties of penguin1 will return the values that are stored on the prototype when I run the code. However, the canFly property is now set on the penguin1 object itself, so it overrides the canFly property on the prototype. This override only affects the penguin1 object. It doesn't change my prototype or other Eagle objects. In this video, you learned about inheritance in JavaScript. Although it is possible to build inheritance using the object_create method, it's probably better to use class syntax for more complex objects and inheritance. Although under the hood, this syntax still works with prototypes, it makes sense to use classes as they improve developer experience in more complex scenarios. Have you ever needed to apply the formatting of text in a word processor from one portion of text to another? In essence, you are copying the properties from some text that is already formatted and applying them to another piece of text that you want to format. In a similar way as with text, JavaScript objects can have properties that define their characteristics. In this video, you will learn how to destructure objects and arrays and also how to use the destructuring syntax to extract new variables from objects and arrays. To illustrate destructuring, imagine that an object or an array is like a project folder that you have on your computer with several files in it. Destructuring something out of an object or array, in this case your project folder, is like copying that item from your folder onto another location. The original item still exists in your project folder. I just made a copy of the original item, but this copy is completely independent of the original item. Now let's explore an example with an existing built-in math object to destructure the value of pi from it. Let's start by using the let keyword and surround the uppercase pi in curly brackets equals math. Because I already know that the pi property exists on the math object, I make a copy of it and I save the new object in a separate variable I name pi. Note that I can only destructure something that already exists on an object. Using faulty spelling, including lowercase, won't work and will return an undefined value. If I type let open curly bracket small case pi close curly bracket equals math, pi returns as undefined. This is because there isn't a lowercase pi property on the math object. So, when I try to destructure it, I get the value of undefined for the lowercase pi variable. The next step is to confirm that all caps pi variable has the identical value and data type as math.pi by using the triple equals strict comparison operator. This will return a value of true. To prove that the destructured property and the original property are in no way connected, I update the value of the pi variable to be 1 by typing pi equals 1. I can now compare all caps pi and math.pi again by typing pi triple equals sign math.pi, thus getting back the Boolean value of false. It's clear that these two are no longer the same. The only reason why this worked is because the original property on the object and the destructured value are not connected in any way. In other words, There's no connection between the destructured variable and the source property on the given object. In this video, you covered how to destructure objects and arrays, and also how to use the destructuring syntax to extract new variables from objects and arrays.
In this video, I'll help you understand the difference between for-in loops and for-of loops when applied to objects in JavaScript. At first, this code may appear complex, but you'll find that it only involves concepts that you've dealt with before. So, let's begin by breaking down what I have. I have a const set to an object and assigned to a variable named car. This object has three properties, engine, steering, and speed, which are given the values true, true, and slow respectively. I also have a const assigned to the variable sports car, and I've used object.create so that it inherits the properties of the car variable. Then I set the speed property of the sports car to fast and save it to the sports car variable. I've also added a console log to display the string, the sports car object, followed by the properties of the sports car object. Next, I have two for loops. The first one is a for-in loop written to log the properties of the sports car object. This is typed as for, followed by properties in sports car in parentheses. Inside of curly braces is a console log for prop, so it displays the properties of the sports car. Before and after the for-in loop code, I've written console logs to print some comments which will be addressed after I run my code. My second for loop uses the object keys method on my sports car object, which should iterate over that object. This is typed as for, followed by prop of objects.keys sports car inside of parentheses. Inside of the curly braces is a console log for prop plus a colon in double quotes and sports car with prop enclosed in square brackets. I've also console logged another comment after this code. When I run this code, I get the output, the sports car object is speed fast. It also displays the comment I had in the code, for-in is unreliable. Let's explore why. From the for-in loop, the console logged values might surprise us. It loops over the property in the sports car object, but the output includes the properties on the sports car's prototype too. Instead of just the speed property, I also looped over the engine and steering properties, which exist on the prototype of the sports car object, not on the sports car object itself. In fact, as the comments state, for-in loops are unreliable in this scenario because they iterate over not only the specified object, but also its prototype. That's why I used a thinking emoji in my comment with the string iterating over object and its prototype. Now, let's examine what came from the second for loop, which is a for-of loop. Note that I output the comment I had in the code for-of is reliable. I've gotten back speed fast, or in other words, the property and value that I've assigned to the sports car object. And just as I have stated in the comment in my code, this is because a for-of loop only iterates over the object's own properties and does not count the prototype at all. Hopefully, you are able to differentiate between the for-in and the for-of types of loops. Let's run a simplified version of the same code without the comments. I'll switch to my other file. This time around, my car object only has an engine property. Then I am declaring the sports car variable and I am setting the car object as the sports car prototype. I'm also setting the speed of the sports car as fast. And finally, I'm console logging the sports car object and looping over prop in sports car and props of object keys in sports car. In summary, the two loops are simplified. I'm only console logging a thinking emoji and the props value for the first loop, the for-in loop. And I'm only console logging a bullseye emoji and the prop and its value in the for-of loop, that is, the second loop in my code. When I run the code again, the result is much simpler. First, I confirm that the sports car object only has one single property, speed, which is fast. Then, the for-in loop displays speed and engine because engine belongs to the prototype of the sports car object and not the sports car object itself. And finally, the for-of loop outputs looping over only the sports car object properties, which in this case is only the property fast. The emojis from my code appear alongside these properties and help us to understand what they mean. And just to sum it up, the speed and engine properties are from the for-in loop because it draws from the prototype of the sports car object as well as the object itself. The speed fast property, however, comes from the for-of loop since that iterates over the sports car object's property only. In this video, you learned that when you run on objects in JavaScript, for-in loops iterate over the properties of the object and its prototype, while for-of loops do this only for the object's properties. In this video, I'll guide you through creating and using template literals in JavaScript ES6 to understand their benefits. First, let's revisit strings in JavaScript ES5, which are built using single quotes or double quotes. I have an example in my code. I've declared a variable no_multiline with the let keyword, which holds the string value no multiline strings in ES5. On the following line, I'm using the console.log method to output the string did you know, followed by the plus operator, and then finally the no multiline variable. Recall that you can use the plus operator for concatenation. When I run the code, I get the expected output of did you know, no multiline strings in ES5. This time, let's change the value of the no multiline variable. To do this, I place my cursor after the word no and press the enter key to move part of the string to a second line. This now spans the string over multiple lines. If we were to run this code now, we would get the error. Also, notice that VS Code is trying to warn us about this error by highlighting the end of lines 3 and 4 with red text and displaying the message unterminated string literal. This is basically JavaScript telling us that our single line string is not coded correctly with the expected closing double quotation symbol. Using ES5 methods, you can only create strings using single or double quotations, and using this method does not support the use of multiline strings. Next, let me clear the output and switch tabs in my code. Here, we have some syntax that may be unfamiliar to you. We have a variable multiline declared with the let keyword, and it contains a string. Like the previous example, this string is distributed across several lines. However, instead of quotes, it's encased within a pair of backticks. This turns it into an ES6 expression known as a template literal. The backtick symbol is usually located above the tab key to the left of the 1 key on your keyboard. Still, it's a good idea to check your device's documentation as you may be using a different keyboard layout. Using template literals, you can add as many lines as you want without causing errors. I can confirm this by running my code. Notice that the output is a multi-line string. But wait, it gets better. We can combine template literals with variable interpolation for even more flexibility. Once again, let me clear the output and continue to the next tab. Here, notice I have two variables called first and second, each containing a single line string encased in backticks. But there's a twist here. Each string also has a segment that sits inside of quotes. Wouldn't this cause conflict, you might wonder? Fortunately, that's not the case. By using template literals, JavaScript does not consider quotes as string delimiters, meaning they are just regular characters here. Now I can use template literals again to interpolate the variables first and second on a different line. Instead of using the plus operator for concatenation, I can simply enclose the full desired string within backticks. I can then place the variable name by enclosing it within a set of curly braces preceded by a dollar symbol. If I run this code, JavaScript combines everything and outputs the full string. With template literals, you don't need to worry about the limitations of using single and double quotes. This can make for a much better coding experience, as you just need to use backticks and variable interpolation. And that's all for this video. Well done! You learned how to build and apply template literals to create multi-line strings and interpolate variables in JavaScript.
Suppose you receive some data on students' test results, and your task is to write a program that outputs an average grade from all the tests based on the raw data. Before you can code this task, you need to consider two separate issues. First, how do you represent the given data in your app? And second, how do you code the solution? Before you even start coding a solution, you need to think about how you will represent the data. In this video, you will learn about some of JavaScript's most common data structures, such as objects, arrays, maps, and sets. A data structure is a way to organize data. For example, you could represent it as a string. However, it would be somewhat of a strange representation. You'd need to somehow extract the numbers from the string before performing calculations on them. Alternatively, you could represent it as several numbers, each number saved in a variable. Doing it this way, you don't have to extract and convert strings to numbers. But is this the most efficient way of storing your app's data? Perhaps another approach would be to store all the grades in an array. This way of organizing your data is even more efficient. It involves less typing, and we're grouping related data together under a single label. You may recall the many benefits of using arrays, but what is important here is that you understand how you code a solution to a given task depends on how you structure your data. In other words, a solution to a coding task depends on the data structure you use. JavaScript is somewhat limited in the types of data structures available compared to other programming languages such as Java or Python. However, some of the most common that you will encounter are objects, arrays, maps, and sets. You may be familiar with some of these already. Let's explore each briefly now. You may recall that an object is an unordered, non-iterable collection of key-value pairs. And you use objects when you need to store and later access a value under a key. An example of using this data structure is when you need to write object-oriented or OOP code. Similarly, you may also recall an array, which is an ordered, iterable collection of values. Likewise, you use arrays when you need to store and later access a value under an index. And remember, we do not specify the index. JavaScript does this automatically. You only use the index to access the specific value stored in the array. When working with arrays, it's common to use a loop, such as a for loop, to access and edit the data. For example, to find the average grade for the task earlier, you could loop over the array and calculate the total sum. Then, after the for loop, calculate the average by dividing the sum by the length of the array. The next data structure is map, which is like an array because it's iterable. However, it consists of key-value pairs. It's important not to confuse a map with an object. With maps, any value can be used as a key. With objects, keys can only be strings or symbols. Finally, the last data structure I want you to know about is a set. This is another collection where each item in the collection must be unique. For example, if you try to add a non-unique item to a set, this operation will simply not be run. In other words, no errors will be thrown and no updates will be made to a set. In this video, you learned about some of JavaScript's most common data structures, such as objects, arrays, maps, and sets. Which one you need to use depends on the task at hand. Next time you have a coding task, try to think of the data structures you might use. The spread operator is another of the many great new additions that came to the JavaScript language in its ES6 update. It is the shortest and simplest method to copy the properties of an object onto a newly created object. Think of the spread operator as a magical multi-purpose tool that can spread out array items and join objects together. In this video, you will explore what the spread operator is and how to use it. Note that the spread operator is characterized by 3 dots. To illustrate where the spread operator becomes useful, let's first build an array, and then call the items with a basic function. Using the variable keyword let, I create an array of the top 3 places to visit on a holiday to Rome, and I call it top 3. Then I include the Colosseum, Trevi Fountain, and the Vatican City as the elements of my top 3 array. Now I write a function that lists these 3 attractions. To keep it simple, I just log it into the console. I create a function and I name it showItinerary, with 3 arguments, place 1, place 2, place 3. Now I console log the 3 places to visit by typing console.log and then the string visit, and the first argument, place 1. Next, I console log the other 2 arguments by first using the strings, then visit, and the argument place 2. And then the string finish with a visit to, and the third argument, place 3. Then, when I run the function showItinerary, it should run through all 3 places. Now, let's try to run the showItineraries function with the elements in the top3 array. I write the function name, showItineraries, and each array element, starting with top3, open square bracket, 0, which is the first element in the array, and close square bracket. Then I do the same for the other array elements, 1 and 2. But what if I extended my function to have 7 places that I want to visit? Let's disregard what the showItineraries function definition may show and imagine that I have made the necessary updates so that the function will handle 7 arguments. I have now built an entirely new array of the top 7 destinations, and I have saved it in a variable named top7. Now, I call the showItineraries function, and passing this function, the 7 arguments again start with 0, as in top7 and 0 within square brackets. Then the array again, top7, and number 1 within square brackets, and so on, until we get to the last top7 array element, which is top7 and number 6 within square brackets. While this code will work, it seems a bit impractical. The spread operator simplifies things. Let's try it now. I type the showItineraries function, then open parenthesis, 3 dots, top7, close parenthesis, semicolon. That's it. I used the spread operator by placing it in front of an array, which is passed to the showItineraries function. The advantage of this approach is that you don't have to list each individual member of the array that you want to pass to your function. The syntax is clear, concise, and easy to type. Now, if I go back to the top3 array, I can use it with the spread operator just like I used it for the top7 array. I type the showItineraries function and the 3 dots, and the array name, top3, within parentheses, and I end with a semicolon. The function returns the combination of the strings and the variables I used earlier. Visit the Colosseum, then visit Trevi Fountain, and finish with a visit to the Vatican City. In this video, you explored what the spread operator is and how you can use it. You might already know that a spread operator in JavaScript is used to unpack a box, for example, to unpack an array. The rest operator, on the other hand, is used to build a smaller box and pack items into it. In this video, you will explore what a rest operator is and how to use it. To illustrate how a rest operator can be useful, consider a travel itinerary. I've realized that there are many things I'd love to see while in Rome during my vacation. Unfortunately, I'm pressed for time, and there's no way to really enjoy all of the attractions, even if I rush to see them all. Let's explore how to solve this itinerary issue. In this case, I can create an array of 7 places that I would like to visit on my holiday to Rome. So I type const top7 to create the array, and I list the 7 places I would like to go within square brackets, with each item in double quotes and separated by a comma. The Colosseum, the Roman Forum, the Vatican, Trevi Fountain, the Pantheon, Piazza Venezia, and the Palatine Hill. To solve the problem, I decide to organize my list in such a way that I have my top 3 attractions and prepare another list for a second visit. To do this, I use the rest operator and a technique known as destructuring. In this destructuring syntax, I simply specify what I want to get out of the top7 array, in this case, the first 3 items. So, I start by typing const, open and close square bracket, equal sign, top7. Then, I create 3 variables, first, second, and third, plus another variable to hold the rest of the list, named second visit. To do this, I type const first, second, third, and then 3 dots and a new variable, second visit, within square brackets, then equals top7 semicolon. With this syntax, I extracted the contents of the top7 array into 4 variables. The variable first with the value of the Colosseum, the variable second with the value of the Roman Forum, the variable third with the value of the Vatican, and then I include the variable second visit. That is a subarray of the rest of the items in the original top7 array. If I inspect second visit, an array of the 4 remaining attractions, Trevi Fountain, the Pantheon, Piazza Venezia, and the Palatine Hill, are all saved as string primitives. The REST operator, therefore, gives us what is left over of the source array as a separate subarray. The REST operator is also useful in functions too. In fact, I can use a REST parameter to quickly multiply values. I create a function to add the tax rate to prices. I name it add tax to prices and give it two parameters, the tax rate and the REST operator with the items bought. The function returns each item with the tax rate. In the add to tax prices parameters, the REST parameter gives me an array, so I can use array methods on items bought using the map method. It's important to know that the REST parameter must be the last parameter in the function definition. This means that adding any other parameter to my add tax to prices function after the REST operator and the items bought would result in an error. In this video, you learned how to use the REST operator, which groups the remaining parameters in a list within a standard JavaScript array. Well done with completing this video on the REST operator. Hello and welcome. Photographers often need different camera lenses for different shooting situations. It wouldn't be very economical to have a separate camera for every need that arises. Fortunately, most systems are modular, meaning the lens can be removed and replaced with a different one as needed. In JavaScript, complex programs can be useful for multiple applications, and it wouldn't make sense to rewrite them over and over. Thankfully, since version ES6, they can be saved and used elsewhere as modules. In this video, you'll cover what modules are in JavaScript, which includes how they work as well as their current limitations. You'll also explore how to use simple ES6 modules in a browser. JavaScript modules are standalone units of code that you can reuse again and again. Being standalone means that you can add them to your program, remove them, and replace them with other modules, and everything will still work. But before we continue, let's explore what things were like before modules entered the picture. In all versions of JS, all functions that are defined on the window object are global. While useful for simple projects, this created some issues when third-party libraries or multiple developers became involved. For example, a global function from one script could override a function from another one, using the same variable name. Techniques were developed to bypass these issues, but they were not without flaws, and so, for a long time, JavaScript lacked built-in, natively supported module functionality. An engineer at Mozilla named Kevin Dangour tried to fix this through a project called Server.js, which was later renamed to CommonJS. CommonJS is designed to specify how modules should work outside of the browser environment. It is mostly used on server-side JavaScript, namely Node.js. A downside of CommonJS is that browsers don't understand its syntax. That is, certain keywords that CommonJS relies on, such as require and module.exports, don't work as expected in browsers. You can learn more about other module systems in the additional reading. But now that you know a bit of the history, let me demonstrate ES6 modules in action. To understand how ES6 modules work, we need to go back to the humble HTML script tag. The script tag comes with a type attribute, which identifies the type of content that it contains. For JavaScript, it is written as script type equals, followed by text/JavaScript in double quotes. To display text in a browser, on the next line I've typed console.log, followed by the string hello from script tag in parentheses, and then a script closing tag. I can even omit the type attribute and use a basic script tag, and the attribute will be set to text/JavaScript by default. To make that happen, I've input an OpenScript tag followed by console.log on the next line and same sample text. I've then added a few more console logs before closing off the script tag. To verify that these script tags work, I'll open a local HTML file in my browser that is linked to this code. When I open the Elements tab in the Developer Tools, it displays the script tags, while the Console tab shows the console log output. Next, let's explore how we can use ES6 modules in a browser. Before starting, I'll open a separate code document. Now, I've changed the value of the type attribute by typing the script tag script type equals module. I've then imported a module called greeting.js. But how do you make it work? To demonstrate, I'll open the associated HTML file in another browser tab. Since I'm running this file locally, access to my script is blocked by a built-in browser security feature called Cross-Origin Resource Sharing, and I receive an error message under the Console tab. To eliminate this error, I need to run the HTML file over a server. I can use a local server for that. For information on how to set up a local server, refer to the additional reading. Now, my greeting.js module is being read in and consumed by this HTML document script tag. In other words, the file's script tags have successfully imported the module. In this video, you've learned about modules in JavaScript ES6. You should now have a better idea of both their uses and their limitations, and you should know how to use basic ES6 modules in a browser. Did you ever think of the functions your TV remote does for you? It allows you to make changes to your TV. You can think of the DOM like a TV remote that lets you change the web page content on the screen. It even allows you to replace only certain parts of the page, such as an image or the heading, or both. A remote, however, has certain limitations. You can only change the channel, contrast, brightness, and volume. The DOM gives you much finer-grained control than a TV remote ever could. For example, imagine you can change what characters in a TV movie look like with a few simple commands while the movie is playing. The DOM allows you to change properties of objects on a web page. You can think of the DOM as a superpower remote for websites. It gives developers power in how they can manipulate and update web pages. The DOM is in the form of a JavaScript object with nested objects for different parts of the page. These objects have nested objects of their own until the entire HTML file is mapped out in what looks like a tree structure. The DOM is the model of the HTML file saved as a JavaScript object in your browser's memory. The browser automatically builds the DOM for every web page that it downloads. For example, if you type a URL into your browser's address bar, the browser will fetch the web page that exists on this domain. If the browser connects to the server and it allows the browser to download the page, it will receive all the HTML code and save it in its memory. The browser will then show the downloaded page. It will also build that web page's DOM, a model of the HTML document your browser has just downloaded. As a developer, you can interact with the page's DOM to make changes to the web page. To interact with the DOM, you can use the Elements tab inside the browser's DevTools. You get to the DevTools by right-clicking anywhere in a browser window and then by clicking Inspect. The Elements tab allows you to interact with the DOM of the currently active web page using a graphical user interface, also known as a GUI. The browser also allows you to interact with the DOM using JavaScript. To do this, you should click the Console tab in the browser's DevTools. You can focus on the console panel by pressing the Escape key on your keyboard. Once done, you can start typing JavaScript commands to view and manipulate the DOM. This is similar to how you interact with the DOM using the Elements panel, only this time you're using code to do it. The entire DOM object is saved inside the document variable and accessible via the console. Now let me demonstrate how DOM manipulation works. Using the document object model allows us to manipulate live websites. For example, I've opened my browser and loaded the example.com webpage from the internet. I want to add a heading 2 HTML element to this webpage using the DOM. Once again, I have the developer tools open in the window to the right, and the console tab is active. It's important to remember that any changes I make to the DOM are relative to my browser's local copy of the web page. I'm not updating the content of the live website, so don't worry, you are not going to break it. If I reload the web page, all changes I make to the DOM will be lost, as it will reset to the page that was downloaded from the server. Okay, so in order to create my heading 2, I need to update the document object. To do this, I type document dot and then the method createElement. Then, inside the open and close parenthesis, I type the name of the HTML element that I want to create, which is wrapped around single quotes. What I am doing here is passing the tag names as a JavaScript string. Finally, I'm going to assign this statement to a const variable. So, I type const h2 and then the assignment operator. I press enter, and now I have successfully built my h2 element. You may notice that the web page on the left has not been updated with the heading 2. This is because although I now have a h2 element saved in JavaScript's memory, I still need to attach it to the DOM structure. Currently, it's not a part of the document object. Additionally, my h2 element also needs some text. Without it, even after adding the h2 element to the document, there would not be a visible change on the page because the added h2 element, although being a part of the DOM, would have no text inside. In other words, it would be blank. Let's fix these two issues now. First, I'll make some updates to my h2 element. I'll add some attributes and some text using the innerText method. I can run this on my h2 variable. I type h2.innerText and then assign a string with a value of this is an h2 heading. Next, I want my heading 2 element to have an ID and a class HTML attribute. To do this, I need to use the setAttribute method. So I type h2.setAttribute, which takes two parameters. The first one is the attribute's name, which is ID, and then the value of the attribute. For this example, I'll name it subheading and press enter. Notice that inside the parenthesis, the name and the value are wrapped in single quotes and separated by a comma. Next, I need to use the setAttribute method again, this time for the class attribute. I've pasted the same line of code, and now I just need to change the word ID to class. And for the value, I change this to secondary and press enter. Finally, I'm ready to append my h2 object to the DOM. First, I can test that my code is correct by typing h2 and noticing the HTML structure's output. This looks good to me, so let's add it to the DOM. I need to run the appendChild method on the document body to do this. So now I type document.body.appendChild, and inside the parenthesis, I place my HTML structure stored in the variable h2. Success! My object is appended to the body of this web page, and the heading 2 text displays in the browser. You should now be able to explain the basics of DOM manipulation and use some of the most common DOM manipulation methods.
One of the most powerful features of JavaScript is DOM manipulation. For example, you can click on a button and change the color of some text or even display a pop-up message. Essentially, you're dynamically updating the HTML content in real time. To do this, you must be able to locate the objects in your HTML document that you want to manipulate. In this video, I'll guide you through how to use selectors in JavaScript to quickly find specific objects in a document. JavaScript selectors work with the document object, which you can access by typing the keyword document. This returns the web page stored in the browser's memory, known as the document object model, or DOM. Alternatively, I can run a console log on the document keyword to get the same result. Let's start locating specific elements inside the document object using the querySelector method. For example, I know this page contains two HTML paragraph elements. To access the first one, I type document.querySelector, then in single quotes inside of the parentheses, I type the letter P. When I press Enter to run the command, it returns the first P element. I can then expand this to view the paragraph text contained within. This method can be used with other HTML elements such as the anchor tag. If I run the same command with the letter A, I get back the first anchor element on the page. There is a very similarly named JavaScript selector that allows me to get all the matches from a web page. It's the querySelectorAll method. To demonstrate this, I type document.querySelectorAll. Inside the parentheses, I pass the P letter as a string, and indeed I get back a result that shows that there are 2 paragraph tags on this page. Another useful JavaScript selector is getElementById, which can find objects in the DOM that match a specified HTML ID attribute. For example, let's say we want to find something on this page with the ID of heading. I type document.getElementById and then the string heading in parentheses. I press Enter and notice that an H1 element is returned assigned with the HTML ID attribute value of heading. Next, let's use a similar method that returns an element based on a specified class name rather than ID. We can do this by calling document.getElementsByClassName. I type document.getElementsByClassName and then the string txt in parentheses. Again, I press Enter and notice that 2 results are returned, the 2 paragraph tags containing the class name of txt. If you are a beginner on your journey with JavaScript, it is important to note that the word element is singular for ID and plural for class name. Additionally, suppose the element you are looking for cannot be found. In that case, you will be returned null for IDs and empty collection represented by square brackets for class names. In this video, you learned how to use JavaScript selectors to speed up the process of finding specific objects in a document.
Let's say you are using a web page on your computer and you click a button, or you tap the like icon on a friend's picture on your phone. In JavaScript, the button click and the like icon tap are examples of user-triggered events. Events are happening all the time. You can use JavaScript code to listen for these events. You can even choose the parts of the page on which you are listening for events. Let me describe an example. You might want to listen for a click event on an Add to Cart button. Once you capture such an event, you might want to run some JavaScript code. For example, I can add a circle with the number 1 on it next to the shopping cart icon to indicate that there is now 1 item in the shopping cart. If the same event gets triggered or fired again, our event handling code then handles the event by updating the count in the circle next to the shopping cart icon. The circle then displays the number 2 to indicate that there are 2 items in the cart. In JavaScript, the function that handles captured events is known as the event handler. Let me demonstrate how to listen for an event by using the addEventListener method. Okay, so I'm back in the console here, and let me demonstrate 2 ways to set up an event listener for HTML elements on a web page. One of the easiest ways to listen for an event is to use the addEventListener method. You can do that on a given HTML element. For example, suppose I want to listen to the click event on the body of this example website. First, I need to get a reference to the body element where we want to listen to this event. In the console of the browser developer tools, I type document.querySelector and then the name of the element inside of the parenthesis. For this example, it's body, and I enclose it with single quotes. Next, I want to assign the body object to a variable, so I type const target equals to assign the body object to the target variable. I've named this variable target because it's the target of our click event. Now I can create a function that will be run when this target is clicked. So I type function handle click, and then in the function body I console log the string clicked the body. The next step is to run the addEventListener method on the target element. So I type target.addEventListener. Then, inside the parenthesis, I pass it 2 arguments. The first is the event type click as a string value, and the second is my handle click function. Okay, so my code is now ready. Let me test it by clicking the web page. Success! Notice that the text is output to the console. In addition to the addEventListener method, an alternative way to listen for events is by using HTML event attributes. Before doing that, let me first write a second-click handler function named handleClick2. Once again, I console log a string inside the function body. This time, it will output the phrase clicked the heading. Next, I need to open the Elements panel of the Developer Tools and expand the view for the div element. Then the heading element should be visible. I right-click the H1 element and click Edit as HTML. Then after the H1, I create the attribute by typing onClick equals, followed by my function name, handleClick2, with a pair of parentheses at the end. Finally, I click outside the element to save the change and return to the console tab. Notice that when I now click on the heading in the web page, the phrase clicked the heading and clicked the body is output to the console. Basically, this single click has triggered two different event listeners, but notice that if I click outside of the heading, it only triggers the event listener that listens for clicks on the entire body element. In this video, you learned how to write an event listener using the addEventListener method, as well as by writing a function directly as a HTML event attribute. Great work!
In this video, I'll help you learn to convert a JSON string to a regular JavaScript object and vice versa. If you type a piece of JSON code into your browser's console, it should not produce any errors. For example, a JSON string with one property named greeting that contains the value of the string hello. If I run this code, I get back the same result. It's worth remembering that JSON is basically just an object represented in the form of a string. It has some specific formatting, but it's a string nonetheless. So to work with JSON, it is common to convert it back to a JavaScript object to work with its properties and methods. To do this, you need to use the global built-in JSON object and its parse method. Let me demonstrate this now. First, I will assign the JSON string to a variable named JSON_str using the const keyword. Next, I'll run the JSON parse method on this variable by typing json.parse and then JSON_str inside the parentheses. I press enter and notice that a regular JavaScript object is returned. I want to save this object as a variable, so I assign the JSON parse method to a variable named aplainobj using the const keyword. Okay, so now that my JSON string is stored in a regular JavaScript object, I can manipulate it just like any other JavaScript object. Let me demonstrate this now by reassigning the value of the greeting property. I type the object name, followed by a dot, and then the object property equals hi. Press enter and notice that the word hi is output. I can confirm this by inspecting the object and notice that its structure has been updated. Okay, that's how you convert a JSON string to a JavaScript object. You can also go the other way and convert a regular object to a JSON string using the stringify method of the JSON object. Let me demonstrate this now. For example, let's start by declaring an object named data and assign it some properties and values. To run the JSON stringify method on this object, I type json.stringify and place the object's name inside the parentheses. The result is a JSON string. Notice that both the object's keys and its values are double-quoted strings in the JSON syntax. It's important to remember that while plain JavaScript objects can hold functions, JSON strings cannot. Another limitation is that valid JSON doesn't allow the use of JavaScript comments. Also, when you stringify a JavaScript object containing a method, that method will be excluded from the stringify operation. In this video, you've learned how to convert a JSON string to a JavaScript object with the parse method, and how to convert a JavaScript object to a JSON string using the stringify method. If you work with retrieving data from APIs, converting the JSON strings to JavaScript objects will be a standard workflow. You can then easily access the object's properties programmatically. This is a vital tool in your tool belt, and I encourage you to practice this.
You've reached the end of this module on programming paradigms. Great work. During this module, you explored the core features of functional programming and object-oriented programming. Let's review the module by summarizing the major items you encountered. The various styles of computer languages are known as programming paradigms. Having studied programming paradigms in this module, you should be able to describe functional programming and how it can be used to solve a problem by separating data from functions. Having explored functional programming, you moved on to another popular paradigm, object-oriented programming, often referred to as OOP. You discovered how OOP differs from functional programming, and you studied object-oriented programming principles. In programming, scope determines which parts of the code are accessible and which parts are inaccessible. You learned how the scope of variables changes when you use the keyword var in ES5 JavaScript, and when you use the keywords let and const in ES6 JavaScript. You should now be familiar with how the scope chain works in JavaScript, and you should also now be able to identify how some of the different types of scope work, including global and local. Much of the development work in JavaScript involves building objects. Classes are essentially a blueprint that you can repeatedly use to build new objects. You can also pass parameters to the class methods and then use them the same as with regular functions. Constructors tell JavaScript how you want your objects to be built. You should now be able to utilize constructors on built-in JavaScript objects. And you learned that inheritance exists in JavaScript, and the inheritance model revolves around the prototype. Additionally, you explored how JavaScript code uses modern features like spread, REST, template strings, and modules. You built code that manipulates the DOM and handles events. And finally, you used JSON in JavaScript. That was a lot to cover, but you should now be more familiar with programming paradigms in JavaScript. Great work!